So students, we are doing numericals from the exercise of chapter 1, electric charges and fields, and we did last time we did the numericals up to 1.8, and now we'll start with the numerical 9th 1.9. so which says, so we are doing chapter 1 NCERT class 12 physics, and exercise question 1.9, which is page number, so it's there in the NCERT. Exercise at the end of the chapter. So question 1.9, a system has two charges QA and QB located at points A. So A point is, so these are the coordinates axis, and this suppose X, Y and Z. So the coordinate is QA is at A 0 0 minus 15. So 0 0 means this is negative Z axis, and 0 0 minus 15. So here we have, this is point A, so QA is over here, and QA is 2.5 into 10 raised to power minus 7 coulombs. Now the B is located at 0 0 plus 15. That's where QB is located at point B. This was point A, and QB is equals to minus 2.5 into 10 raised to the power minus 7 coulombs. So that's what QB is. Now we need to find the total charge and electric dipole moment of the system. So total charge of the system. So charge is a scalar quantity, so we can simply add the charges. So charge is 2.5 into 10 raised to power minus 7 minus 2.5 into 10 raised to power minus 7. So charges are equal and opposite, so of course they will cancel out each other. So the net charge of the system is 0. Now what is dipole moment? So dipole moment P is equals to Q into, so one of the charges into distance between them, that is 2A. So this is so one of the charges magnitude we can take, and that is 2.5 into 10 raised to power minus 7 multiplied by, what is the distance between them? So the distance between them is so this is in centimeters, right? So 15 centimeter plus 15 centimeter, the distance between them is 30 centimeter, and 30 centimeters equals to 0.3 meters. So that is our 2A. So 0.3, and this comes out to be 0.75 into 10 raised to the power minus 7 coulombs meter. And so dipole moment is a vector quantity. So we have told the magnitude, and now we will tell the direction. So direction, so dipole moment acts in the direction from positive charge to negative charge, from positive charge to negative charge, that is along negative z axis. So students, so charge was a scalar quantity, so magnitude, answer. Now second part was dipole moment. So dipole moment is a vector quantity, so we write the magnitude first and then we have written the direction. Now the next question, 1.10. An electric dipole with dipole moment 4 × 10⁻⁹ Coulomb meter. So this is the dipole moment that is given to you in the next question. It is aligned 30 degrees with the direction of the electric field. So if this is the direction of the electric field, then the dipole moment, which is from positive charge to negative charge, this is the direction of dipole moment and this is the direction of electric field. So it is making an angle 30 degrees. So this angle is 30 degrees, and so theta is equals to 30 degrees here, and magnitude of the electric field is equals to 5 × 10⁻⁻⁴ Newton per Coulomb. Now we have to calculate the magnitude of the torque. So we have to calculate the torque acting on the dipole. So torque we know is equals to, so we only need to find the magnitude of the torque. So magnitude of the torque will be given by P E sine theta. So because torque is equals to P cross E, so the magnitude will be Pe sine theta. So and n cap, so we need to find the magnitude only. P sine theta, P is given to us, E is given to us, and sine, so we can simply find the values. So put the value 4 × 10⁻⁹ into 5 × 10⁴ into sine 30. So what is sine 30? 1/2. So this comes out to be 10⁻⁴ Newton meter. So very simple numericals. Students, always try the numerical or by yourself. You can pause the video and solve the numerical yourself and then check your answer. So it's better if you try the numerical yourself. Next question. A polythene piece rubbed with wool is found to have a negative charge of 3.2 × 10⁻⁷ Coulomb. So the charge is 3.2 × 10⁻⁷ Coulomb. Estimate the number of electrons transferred. So when a polythene piece is rubbed with wool, so polythene piece rubbed with wool, so is found to have negative charge. So this polythene piece is found to have a negative charge of 3.2 × 10⁻⁷ Coulomb. So it means wool has acquired positive charge. So obviously electrons has been transferred from wool to polythene piece. So exactly same charge will be there on the wool. Now how many electrons are transferred? So charge is equals to, so quantization of charge, Q is equal to NE. And so what is, we know the value of E. So E is equals to fundamental charge, that is charge on an electron or proton, that is 10 to the power minus C, that has 1.6 into 10 to the power minus 19 coulombs. So N is given to us, E, so number of electrons we can find, that is Q by E. So that is equals to 3.2 into 10 to the power minus 7 divided by 1.6 into 10 to the power minus 19, and this comes out to be 2 into 10 to the power 12. So these many number of electrons transferred from wool to polythene piece. So while rubbing, it transferred. Second part, is there a transfer of mass from wool to polythene? So definitely electrons has mass. So if electrons are transferred, so mass is also transferred. So mass transferred, so total mass transferred is equals to number of electrons into mass of one electron. So number of electrons transferred is 2 into 10 to the power 12, and mass of one electron is 9.1 into 10 to the power minus 31 kilogram. So the net mass transferred is 1.82 into 10 to the power minus 18 kilograms. So clearly this is very, very small, almost negligible. You cannot detect it. You cannot weigh it. So such a small mass, but still, yes, there is mass transfer, but that is 10 to the power minus 18 kilogram, almost negligible, very, very small. Okay, next question. A part, two insulated. So students, my suggestion is that you should try the numericals yourself, and then if you don't know the answer, then you can see the solution. So we have two insulated copper spheres, A and B, and they have their centers separated by distance 50 centimeter. So we have these two spheres, and the centers are separated by distance of 50 centimeter, that's equals to 0.5 meter, half meter. What is the mutual force of electrostatic repulsion if the charge on each is, so the charge on this sphere is 6 into 10 to the power minus 7 and 6.5 into 10 to the power minus 7 Coulomb. So what is the mutual force of electrostatic repulsion? So obviously we have the Coulomb's law. So Coulomb's law says that force is equals to K, Q1 magnitude of that force divided by R square. So this comes out to be 9 into 10 to the power 9 into the charge is 6.5 into 10 to the power minus 7, and same, so multiply it with 2 and divided by distance 0.5 whole square. And student, if you calculate it, you will get it 1.5 into 10 to the power minus 2 Newton. So that's the mutual force. So according to Newton's third law, the force is equal and opposite. So both are repelling each other. So it's the force of repulsion, because like charges, so force of repulsion between them. The radii of A and B are negligible compared to the distance of the separation. So also compare this force with the mutual gravitational attraction if each weight 0.5 kilogram. Okay, so this weighs 0.5 kilogram, it also weighs 0.5 kilogram. So this was electrostatic force, and now we have to find the gravitational force. So gravitational force is equals to G m1 m2 by r square, and this equals to, so gravitational force is 6.67 into 10 to the power minus 11 into, sorry students, this we are not adding the charges, we are multiplying the charges. So this will not be 2 here, but this is square, so multiplying it 2 times. So here also it is 0.5 square, so 0.5 into 0.5 divided by distance also 0.5 into 0.5. So this will completely cancels out, and hence the force is 6.67 to 10 to the power minus 11 Newton. So we can clearly see that this is 10 raised to the power minus 2 Newton, and this is 10 to the power minus 11 Newton. So clearly Fg is much smaller than electrostatic force. Now this B part of this question, what is the force of repulsion if each sphere is charged double the above amount and the distance between them is halved? So charge is doubled and the distance is halved. So this is Q dash and R dash. So what is the force of repulsion now? So force of repulsion will be equals to, so this formula changed, Q, and now the charges are twice, so 2Q1 2Q2 divided by radius is R by 2. So this comes out to be K, so into 4 Q1 Q2 divided by R square upon 4. So this comes out to be 16 times, so this force F dash, so this force Fe, so F dash is 16 times, so 4 will go, so divided means 4 upon R square, so 4 for the 16, and K Q1 Q2 by R square is Fe, so 16 times Fe. So simply multiply this with Fe, we'll get this as, so 16 into 1.5 into 10 to the power minus 2, that's equals to 0.24 Newton. Now we have to find if the two spheres are placed in water. So this was vacuum here or air, and now there is water in between the spheres. So now these are the spheres and there is water in between them. So now we will have the formula for the electrostatic force. So this will be F E double dash, because here K is changed. So let us see what the K is. So K is equals to 1 upon 4 pi epsilon naught. And now this is permittivity of the free space, but now we have permittivity of the water. So this is permittivity of water, and permittivity of water, so, and that is equals to K dielectric constant epsilon naught. So K is equals to upon epsilon naught. So put the value of so for water, so see this K will always be this greater than 1. So here K for water is actually given to us. K is equal to 80. So this K will become 1 upon 4 pi. So put the value of permittivity of water, epsilon naught into K. So here this will be the value of K, and this value of K is given to us, that is 80. So now this formula, this K, this is Coulomb's constant and this is dielectric constant. Okay, because this equals K upon K. So this is K dash, we can say. So this K dash will be K upon K, and rest of the things are same. So it means this is Fe upon K. So Fe is our 1.5 into 10 to the power minus 2 divided by 80. That is dielectric constant of water given to us, and this comes out to be 1.9 into 10 to the power minus 4 Newton. So if you put water, then obviously the Coulomb's force has become weaker. So it is weaker by 1 by 80 times, so divided by 80. Okay, so that's the answer. Very important question we have done. Now the next question. Let us do now example 1.13. So example 1.13 has A and B, which were there in the last question, have identical sizes. So they are of identical sizes, and a third sphere of same size but it is uncharged is brought in contact with first and then brought in contact with second and finally removed from both. And what is the new force of repulsion between A and B? So when A, so this is A, this is B. So when A comes in contact with C, so it has charge Q, A has charge Q let, and C has charge 0. So now okay, what we can do is we can make them separately. So when they were separate, it has charge 0 and it has charge, so C has charge 0. But now as they are touched, So now A and C have charge q by 2, q by 2. So first of all, find the net charge, that is q plus 0 is equals to q. So q is the net charge and that net charge is equally distributed. So first of all, find the net charge and then distribute it equally. So that's the case with A and C. Same will be the case. Now this so now we have touched B with C. So now this is your B charge, this is a B charge, this is your C. Now what is the charge on B? Charge on B is Q. What is the charge on C? Charge on C is Q by 2. So C was touched with A first and then C acquired a charge of Q by 2. Now it is touched with B. So again I told you, find the net charge. So what is the net charge? Q plus Q by 2, that is 3Q by 2. And now this will be equally distributed when B and C is touched. So half of it, that is 3Q by 4 and 3Q by 4. So B and C will have this charge. Now what is the force of repulsion between A and B? So this is now A and this is B, and they are r distance apart. So this is A and this is B. So charge on A is, this is the charge on A and this is the charge on B. So charge on A is Q by 2, charge on B is 3Q by 4. So force of repulsion by Coulomb's force, Coulomb's law, is given by K Q1 Q2 by R square, and that's equals to K is so here let us put this value before value of Q1 has become Q by 2 and Q2 has become 3Q by 4 divided by R square, and that's equals to 1 by 8 KQQ by R square. So that we have already calculated, 1.5 into 10 to the power minus 2 Newton. So that is 1 by 8 Fe. So 1 by 8 into Fe we have already calculated, 1.5 into 10 to the power minus 2 Newton, and this comes out to be approximately equals to 5.7 into 10 to the power minus 3 Newton. So the force of repulsion is reduced by 1 by 8. So reduced by, and it is reduced to 5.7 into 10 to the power minus 3 Newton. Now the next question, so students, as I am regularly telling you that you should first of all try these numericals yourself one by one, and if you don't know the answer then you can look at the solutions. So that's a better way of doing these questions. So now we have question 1.14. So what is this question 1.14? 1.14 says that figure is given to you. Students, open your NCERT books. If you have not opened still, so you have this figure. So exercise question 1.14. So we have this figure in your book. This is positive charge plate. This is negative charge plate. And we have 3 charged particles. So obviously I told you earlier also that we have uniform electric field. So this is the way how to create a uniform electric field here. So its direction will be from positive plate to negative plate. So now we have 3 charges, and the tracks of these 3 charges is given to us. So first charge comes here and went this way. Second come again go this way, whereas third one is deflected this way. So so you need to give the sign of the 3 charges. So obviously 1 and 2 are attracted towards the positive plates, so they are negatively charged, and 3 is attracted towards the negative plate, so it is positively charged. Now which particle has the highest charge to mass ratio? So which one is deflected, deviated more? So this deflection is maximum. This deflection is maximum, and deflection is directly proportional to the ratio of the charge to mass of the particle. So therefore we conclude that ratio of charge to mass is maximum for particle number 3. So deflection is directly proportional to the charges to mass ratio. So more is the deflection, more is the charge to mass ratio. So students, that was question 1.14. Now question 1.15. This question 1.15 has been there in the board exams also in 2013. So now the questions of flux start, and I tell you that, let me remind you that flux has 2 formulas. One is by definition E dot S, and second by Gauss law, that flux through the Gaussian surface is the charge enclosed by the surface epsilon naught. So if you are concerned with E, then use this definition of the flux, and if you are concerned with the charge, then use the Gauss law. So these are the things that you need to remember while doing the numericals related with flux. Now we have a uniform field given in this question, and this field is 3 into 10 raised to power 3 I cap so the field is 3 into 10 raised to power 3 I cap Newton per Coulomb, and so we have to find the flux of this field through a square of side so students, what is the flux of this field through a square of square, so not a cube but a square, so square is 2D, so square is there given to us and whose side is 10 centimeter, so 10 centimeter means 0.1 meter, whose plane is parallel to YZ plane. So what is the flux through this field? So electric field is clearly, this I cap means X direction, so field is in X direction and the square is in YZ plane. So this is YZ plane. Now the normal to this plane will be in the direction of the electric field. So the angle between the plane means plane vector and electric field is 0 degree. So now what is the flux? So flux is equals to, so related with electric field, so E dot S, and this comes out to be electric field is 3 into 10 raised to power 3 into, so that is ES cos theta, and theta is equals to 0 degree here, so that is 1. So and what is S? S is the surface area of the square, and surface area of the square is 0.1 into 0.1. So now this flux comes out to be 30 Newton meter square per Coulomb. So quite simple. Second part of this question, what is the flux through the same square if the normal to its plane makes an angle 60 degree with the x-axis? So now theta has become 60 degree, so phi is equals to E dot S is equals to ES cos 60 degree this time. So ES is 30 into cos 60 is 1 by 2, so that is 15 Newton meter square per Coulomb. So this is the flux. So at 60 degree the flux is reduced to half. So this is important thing for you. Now we have next question. Consider a uniform electric field E, same as above. What is the net flux of this field through a cube of 20 centimeter oriented so that faces are parallel to the coordinates plane? So what is the net flux? So the flux entering, so now we have a cube. So the flux entering one face parallel to YZ is equal to the flux leaving other face parallel to the YZ plane, and flux through other faces is 0. So 1.16 we can draw the figure. So flux through this face is, and flux through this face. So electric field has only X component. So an electric field is uniform. So the number of lines entering from here, number of lines leaving from here. So, and here there is no flux through these 4 faces. So the flux is through these 2 faces, and flux entering is equals to flux leaving, and through these 4 surfaces there is no flux coming out. Theta is 90 degree for all these faces and 0 degree, but the net flux of the field means the net flux coming out of the surface. So here the flux entering this face on the left hand side is equal to the flux leaving the other face. So you can so the net flux through the cube is 0. And if you want to understand it mathematically, so this is the area vector of this face. So the angle is here 180, and cos 180 degree is equals to -1. So the flux here through this left face is equals to -E if the surface area is S minus ES, and flux through the right hand space theta is equals to 0 degree, so ES. And flux is a scalar quantity, so you can simply add them. So flux through left hand face plus flux through right hand face, and that is equals to -ES plus ES, that's equals to 0. So this was question 1.6. Now 1.7. Careful measurement of electric field at the surface of a black box indicates that net outward flux to the surface of the box is 8.0. So 1.17. So we have black box. So we have a black box. Suppose this is the box, and net outward flux through the surface of the box is, net outward flux is 8 into 10 raised to power 3 Newton meter square per Coulomb. So first thing is, what is the net charge? So see here, as I told you that flux has 2 formulas. One is by definition and this is Gauss law. So write these 2 formulas as the question related with flux comes. So this flux is nothing but adding all the flux through all the surfaces. So flux through means we are adding up the flux through all surfaces. So like phi1 plus phi2 plus and so on. So like here we did like phi L plus phi R, and for rest of the faces the flux was 0. So which case, so we need to find the net charge enclosed. So obviously we need to use this Gauss law. So according to Gauss theorem, according to Gauss law, phi, so flux through the closed surface, so the closed Gaussian surface, electric flux is equals to Q by A. So this is the charge enclosed, and charge enclosed is equals to epsilon naught phi, and phi is given to us, and epsilon naught is so we know that this is 1 upon 4 pi epsilon naught is equals to K is equals to 9 to 10 power 9. So phi naught can be written as 1 upon 4 pi 9 to 10 power 9. So that's equals to 1 upon 4 pi into 9 into 10 power 9 into the flux, which is 8 into 10 power 3, and this comes out to be 0.07 into 10 power minus 6 Coulomb. This is 0.07 micro Coulomb. So that is the charge enclosed. Next is, if the net outward flux through the surface of the box were 0, could you say that there were no charges inside the flux? So the second part is of this question is that outward flux is equals to 0. Okay, it means that is equals to this. So it means charge enclosed is equals to 0. So does it mean that there are no charges inside the box? Why or why not? We cannot say anything. So do we conclusion? Do we conclude that there is no charge? No. We cannot conclude that there is no charge inside. We can only say that Q net is equals to 0. So there might be equal and equal positive, suppose 2 Coulomb and 2 minus Coulomb, so the net enclosed is 0. So we cannot say anything about the charge. So charge enclosed is 0. So there can be two cases: either either there is no charge inside, or the second thing is that there is equal and opposite charge inside, which is cancelling out each other. Now we have another question, 1.18. So a point charge of 10 microcoulomb is at a distance 5 centimeter directly above the center of a square of side 10 centimeter. So we have this square. So this is a square, and this side is 10 centimeter and this side is also 10 centimeter. This is not to the scale, this figure, and we have a charge over here that is Q, and this distance is 5 centimeter, that is equals to 0.05 meters, and this is equals to 0.1 meter, and this Q is a point charge that is plus 10 microcoulomb. What is the magnitude of electric flux through the square? So students, here we need to think this square as one of the faces of the cube, because then only it will be easy to find the answer. So we can assume that this is one of the faces of the cube. So this is the whole cube, and this is one of the faces of the cube, because it is quite easy, because by the Gauss law we know that charge enclosed upon, so phi is equals to q upon epsilon naught, so that's Gauss law. So this is total flux through the Gaussian surface. So here all the 6 faces are identical and equal flux will go out from all the 6 faces. So let the flux through one of the faces, even through this faces, phi s. So phi s through this surface, phi s through this surface, so phi s from all the 6 surfaces. So this total flux will be equals to 6 into phi s, and that's equals to q by epsilon naught. Now we have to calculate this phi s, flux through this surface. So phi s is equals to q upon 6 epsilon naught, and this comes out to be 1 upon 6 into this is 10 microcoulomb. So 10 microcoulomb is 10 to the 10 power minus 6 coulombs into epsilon naught is, so 1 upon 4 pi epsilon naught is equals to 9 into 10 power 9. Units are not required, so epsilon naught is equal to 4 pi 9 to 10 power 9. So that's the value of epsilon naught. So 4 pi into 4 pi into 9 into 10 power 9, and this comes out to be, if you calculate this comes out to be 1.88 into 10 power 5 Newton meter square Coulomb square. So these examples related with flux are quite easy, students. Let us do one more question. 1.19. A point charge of 2 microcoulomb is at the center of a cubic Gaussian surface 9 centimeter on edge. What is the next flux through the surface? So Q is 2 microcoulomb here, and that's equals to 2 into 10 power minus 6 coulomb, and according to Gauss theorem, phi E is equals to Q by charge enclosed by epsilon naught, and charge here is 2 into 10 power minus 6. So, and epsilon naught, we know the value, 4 pi into 9 into 10 power 9, and this much we can calculate it, and this comes out to be 2.26 into 10 power 5 Newton meter square per coulomb. So here we were dealing with Q. So Gauss law, if you are dealing with electric field, use the formula of the flux E dot S, and if you are dealing with charge, then Gauss law. So students, only these 2 formulas you need to do, and so we will do rest of the questions tomorrow. So thank you for watching these videos. Always practice the question first yourself, and if you are unable to find it, then only see the solution, then only it will be beneficial. And write, if you find any question difficult, write D on it, and you can revise those questions again. Along with that, always have a formula sheet of the chapter, and that formula sheet must have, if there is any figure with that formula, figure should be there, units, SI unit should be there with the formula, and do the questions quite simple. Remember, hard work is the only key to success, and practice makes a man perfect. That's all for today. Thank you so much. See you tomorrow.